This is Opokuari e-learning virtual classroom, and this is SHS2 integrated science class. And today we are going to continue with where we ended last week. Last week we ended with acid, and today we're going to look at the preparation of gases. In our previous lesson, we got to know that acids react with metals to liberate hydrogen gas. We also got to know that acids react with triisocarbonate 4 or carbonates to liberate carbon dioxide or carbon dioxide. So today we are going to look at acid, reaction of acid with metals. And as I mentioned, acids react with metals above copper on the reactivity series to liberate hydrogen gas. For instance, you have zinc metal. So zinc metal reacts with hydrochloric acid, and that will go in to produce zinc chloride plus hydrogen gas. Zinc chloride, hydrogen gas. So the hydrogen or the metal displaces the hydrogen in the acid to produce salt, and we have hydrogen gas being liberated. Now, let's look at the setup for producing hydrogen gas. If you look at the setup, we have tester funnel, we have flat bottom flask, delivery tube, beehive stand, gas jar, then we have water trough, and here we have water, we have bubble of gases moving up there. So we have hydrogen in the gas jar. Now look here, we have something called functional diagram. So in exam, when you ask to draw the setup for preparing hydrogen gas, we look out for what we call functional diagram. Now look at this. You can see that the tester funnel is inside the reactants. Again, you can also see that the delivery tube is hanging here. So take note of that. In exam, when we ask you to draw the setup, we look out for what we call the functional diagram. And you have to make sure that the tester funnel is inside the reactants in the flat bottom flask. Again, your delivery tube is hanging. Now, you should also know that the delivery tube enters the beehive stand. So we have three things here: tester funnel inside the reactant, delivery tube hanging in the flat bottom flask, delivery tube entering the beehive stand. So let's take note of that. Now, let's look at properties of hydrogen gas. Hydrogen gas is colorless and odorless. So it has no color, it has no scent. Again, hydrogen gas is lighter than air. Hydrogen gas is lighter than air. So don't forget that the delivery here is upward delivery. So take note of that. Hydrogen gas, the delivery of hydrogen gas is upward delivery. Hydrogen gas is lighter than air. Again, it is insoluble in water. Hydrogen gas does not dissolve in water. Again, it has no effect on litmus paper. So you can say that hydrogen gas is neither acid nor gas. Again, hydrogen gas forms explosive mixture with oxygen. And finally, it is a reducing agent. So now that we know the properties of hydrogen gas: 1, colorless and odorless; 2, lighter than air; 3, insoluble in water; 4, it has no effect on litmus paper; 5, it forms explosive mixture with oxygen or air. Again, it is a reducing agent. Now let's look at the uses of hydrogen gas. What are the uses of hydrogen gas? 1, it is used in herbal process it is used in Haber process to produce ammonia, right, with nitrogen. It is used in Haber process. Good. So this is Haber process. Hydrogen gas is used in Haber process to produce hydrogen. It is used in Haber process to produce ammonia, right? It is used in Haber process to produce ammonia with hydrogen. So, uses of hydrogen gas. Number one, it is used in Haber process. It is used in Haber process to produce ammonia with hydrogen. And I hope you know that ammonia is a nitrogenous fertilizer, which is very, very important in farming. Again, it is used as fuel for rockets. Hydrogen gas is used as fuel for rockets. Again, it is used in hardening. It is used in hardening palm oil or vegetable oil to produce margarine. Hydrogen gas is used in hardening vegetable oil or palm oil to produce margarine. Number four, it is used for filling balloons. It is used for filling balloons. Don't forget that hydrogen gas is lighter than air, so we can use it to fill balloons. Again, oxyhydrogen flame is used for welding and cutting of metals. So oxygen and hydrogen, right, can be combined to produce a flame or a torch that can be used for welding and cutting of metals. Again, it is also used as reducing agent. It is also used as reducing agent to remove oxides from metals so that we get the pure metal. So it is used as a reducing agent to remove metallic oxides in order to produce the pure metal. Now, let's also look at how hydrogen gas is tested for. So in the first place, we know how hydrogen gas is prepared. 2, we know the properties of hydrogen gas. 3, we know the uses of hydrogen gas. Now let's look at how hydrogen gas can be tested for. So test for hydrogen gas. Now, take note of this. Sometimes when you ask candidates to give you how hydrogen gas is tested for, good, then they'll tell you it gives pop sound. It gives pop sound. You score 0 for that. Why? Because you have to tell your examiner, right, how to carry out the test. So in the first place, when glowing splint, so this mentioning glowing splint will give you a mark. When glowing splint is introduced into hydrogen gas, it burns with pop sound, and that will earn you another mark. So take note of that. When glowing splint is introduced into hydrogen gas, it burns with pop sound. It burns with pop sound. So don't just go straight and write, it gives pop sound. You have to tell us what to do. So glowing splint, when glowing splint is introduced into hydrogen gas, it burns with pop sound. So that is how hydrogen gas is tested for. Good. Last week, we also got to know that acids react with carbonates or triazocarbonate form to liberate carbon 4 oxide or carbon dioxide. Acids react with carbonates to liberate carbon 4 oxide. Now, let's look at this. For instance, you have calcium triosocarbonate 4. Calcium triosocarbonate 4. So this is a carbonate. And you add this one to acid HCl. What happens? You have calcium chloride plus water plus carbon 4 oxide, CO2, carbon 4 oxide. Good. So carbonate, we have calcium triosocarbonate 4. Then we have hydrochloric acid, and that will go in to produce calcium chloride, we have water, then we have carbon 4 oxide or carbon dioxide. So this is how carbon 4 oxide is produced. When carbonate is reacted with acid, carbon 4 oxide is produced. And now, let's also look at this. Let's look at the properties of carbon dioxide. Properties of carbon dioxide. So what are the properties of carbon dioxide? Don't forget that now we know the properties of hydrogen gas. So what are the properties of carbon dioxide? Properties of carbon dioxide. Properties of carbon dioxide or carbon 4 oxide. Let's move on. One, it is colorless and odorless. It is colorless and odorless. It is colorless and odorless. So carbon 4 oxide has no scent. It has no color. It is colorless and odorless. Again, it is denser than air. It is denser than air. And as you know, hydrogen gas is lighter than air, but carbon dioxide or carbon 4 oxide is denser than air, or it's heavier than air. Again, it is soluble in water. Unlike hydrogen gas, which is insoluble in water, carbon 4 oxide is soluble in water. It's soluble in water to form weak carbonic acid. Weak carbonic acid. Good. It is colorless and odorless. It is denser than air. It is soluble in water to form weak carbonic acid. Again, it does not support combustion. It does not support combustion. It does not support combustion. Support combustion or burning. Good. So don't forget, when we get to the uses of carbon dioxide, you understand the reason why carbon dioxide is used as fire extinguisher. This is very clear here. Again, it turns lime water milky, right? It turns lime water milky. All right. Very good. So these are some of the properties of carbon 4 oxide or carbon dioxide. Colorless and odorless, denser than air, soluble in water to form weak carbonic acid. It does not support combustion or burning. It turns lime water milky. So these are the properties of carbon dioxide. And now, let's look at uses of carbon dioxide. Uses of carbon dioxide. What are the uses of carbon dioxide? Uses of carbon dioxide. Uses of CO2. Number one, it is used to manufacture. It is used to manufacture fire extinguisher. It is used to manufacture fire extinguisher. So if you have a gas which does not support burning or combustion, then that gas can be used to fight fire. So carbon dioxide is used as fire extinguisher or in the preparation of fire extinguisher. Again, it is used to preserve fruits, or it is used in fruit preservation. So for instance, you have your pineapples, your bananas, and you are exporting them to UK or US. It will take some time before you get to UK market or you get to US market. Now, what do? You have to store the fruit under carbon dioxide in order to preserve them. So carbon dioxide or carbon dioxide is used for fruit preservation. Number three, it is used in fizzy drinks. It is used in fizzy drinks. Fizzy drinks like Coca-Cola. So you open the bottle of Coca-Cola and you see a effervescence of this smoky gas coming out of the Coca-Cola. And that is CO2. That is CO2. Then it's also used as refrigerant. It is also used as refrigerant. So you'll find refrigerants being used, right, to fill deep freezers, to fill fridges and air conditioners, right? So carbon dioxide is used as a refrigerant. And again, it is used in bread making. Number five, used in bread making. And somebody may ask, but how do we use carbon dioxide in bread making? You see, when you add yeast to the dough, you cover the dough, you provide an anaerobic environment for fermentation to take place. And when fermentation takes place in the dough, CO2 is produced. And the CO2, in an attempt to escape from the dough, causes the dough to rise. Very good. So CO2 is used in bread making. So now that we have the uses of carbon dioxide or carbon dioxide, let's also look at how we test for carbon dioxide. How do we test for carbon dioxide? How do we test for carbon dioxide? In the first place, you see, sometimes you pick candidate script and they write, it turns milky. And if you put that statement down, you will not get any marks from that. It turns milky. What turns milky? So you should tell your examiner that when carbon dioxide is passed through, lime water, it turns milky. It turns milky. When carbon dioxide is passed through lime water, it turns milky. But let's ask ourselves, what happens? What brings about the milky nature when carbon dioxide is passed through lime water? And you should be able to tell your examiner that something happens, right? And let's take note of that. In the first place, you have the lime water. Lime water is calcium hydroxide. Calcium hydroxide. This is your lime water plus carbon dioxide, and this is your gas going in to produce Ca, that's calcium CO3 calcium triosocarbonate plus water. Good. All right. Now let's continue. So calcium hydroxide is the same as lime water. So your lime water is calcium hydroxide. Calcium hydroxide. Okay. Action. All right. So we have your lime water plus carbon dioxide or carbon 4 oxide, and that will produce calcium triosocarbonate 4. Then we have water. And now look here. It is this calcium triosocarbonate 4 that gives the milky nature of the solution when carbon dioxide is passed through lime water or calcium hydroxide. This gives the milky nature of the solution. So take note of that, because we can ask you to tell us why lime water turns milky when carbon dioxide is passed through it. It's because of the formation of calcium triosocarbonate 4, popularly known as calcium carbonate. All right. So now that we know how to test for carbon dioxide or carbon 4 oxide, let's move on to bases. So now we finish with acids. We finish with the chemical reaction of acid with metal with carbonates, and these two gases are produced, the hydrogen gas and the carbon 4 oxide. So now we are looking at bases. What are bases? Don't forget, last week we got to know that acid is defined as a proton donor. Acid is defined as a proton donor according to Bronsted-Lowry definition. Now, what are bases? According to Bronsted-Lowry definition, a base is a proton acceptor. So as acid donates proton, bases accept proton or hydrogen ion. So a base is a proton acceptor or hydrogen ion acceptor. Again, you can also define bases as substances that produce hydroxyl ions. Substances that produce hydroxyl ions. Hydroxyl ions in aqueous solution. Hydroxyl ions in aqueous solution. So bases can be defined as proton acceptor or a substance that produces hydroxyl ions in aqueous solution. Good. Then don't forget, a base which is soluble in water is known as alkali. A base which is soluble in water is known as alkali. So alkali are bases that dissolve in water or that readily dissolve in water, or soluble base is known as alkali. But you see, when alkali dissolves in water, it produces a solution. So a solution produced from the alkali being dissolved in water is termed as alkaline. So just get to know the difference between the two terminologies. Alkali is a base which is soluble in water. Alkaline is the solution formed when a soluble base is dissolved in water. So take note of that. Now, Bases can also be grouped into two: strong bases and weak bases. And what makes a base a strong base? A strong base is defined as a base, right, which ionizes or dissociates. Ionizes or dissociates. A strong base. A strong base. Strong base. A strong base is a base that ionizes or dissociates completely. Completely. Take note of this word. Ionizes or dissociates completely in aqueous solution. In aqueous solution. Right? A strong base is a base that ionizes or dissociates completely in aqueous solution to release more hydroxyl ions. More hydroxyl ions, which is, so now we have three keywords here. They ionize or dissociate completely in aqueous solution to release more hydroxyl ions, which is, right. So that is how we define strong bases. Example of strong bases, we have sodium hydroxide. Sodium hydroxide. We have potassium hydroxide. These are few examples of strong bases. Now, let's also look at weak bases. What are weak bases? What are they? Now, a weak base is a base that dissociates partially. So take note. It dissociates partially in aqueous solution to release small amounts of hydroxyl ions, OH minus, with difficulty. So we have three things here. Partially, they dissociate partially, or they ionize partially. And when they ionize partially, they release small amount of hydroxyl ions with difficulty. So that is the definition for weak bases. Example of weak bases, we have ammonia. Ammonia is an example of a weak base. Urea is an example of a weak base. Okay, so now we know strong base, right, as the base that dissociates completely in aqueous solution to release large amount of hydroxyl ions with ease. However, weak base is a base that dissociates or ionizes partially, right, in aqueous solution to release small amount of hydroxyl ions with difficulty. And typical examples are ammonia and urea. So I entreat my students to look out for more examples of weak bases and strong bases. Now let's also look at properties of bases. I hope you remember last time we considered the properties of acids. So today we are going to consider the properties of base or bases. What are the properties of bases? Number one, they are corrosive. They are corrosive. right, when concentrated and in solid form. So bases are corrosive when they are concentrated and they are also in solid form. Again, we should also know that bases have pH, right? They have pH greater than 7. They have pH greater than 7. We should take note of that. Again, they have soapy or slippery feel, right? So they feel like a soap. They feel like soap, right? They have soapy or slippery feel. Again, we should also know that they taste bitter, right? They taste bitter. But we got to know in acid that acids taste what? Sour. Very good. So let's move on. Again, they also react with acids, right? Bases react with acids. They react with acids to produce salts, right? In neutralization process. Neutralization process. And I hope you remember this. We mentioned this in the properties of acids. So take note of that. Again, take note of this. They react with ammonium salts. They react with ammonium salt to liberate or produce ammonia gas. Ammonia gas. So you can see that the last 2 points are the chemical properties. The last 2 points are the chemical properties. So they react with ammonium salt to liberate ammonia gas. All right. So let's back our claim here with a chemical equation. So for instance, you have ammonium chloride, NH4Cl, plus a base like KOH, potassium hydroxide. Then what do? You can see that you have a salt being produced here. Potassium chloride plus water plus ammonia gas. Again, we can also look at uses of bases. Now take note of this. We know how we can categorize our bases. We have strong bases, we have weak bases, and we know what a weak base is, a strong base is. Again, we also know the properties of bases. Let's look at uses of some bases. In fact, we have a quite number of bases, and I hope you remember last time we considered a quite number of acids and their uses. So let's look at uses of some selected bases. Not all the bases. We can't deal with all the bases here in this lesson. So we have some few bases, and one of the important bases we know is sodium hydroxide. So let's look at uses of sodium hydroxide. And it's very popular in our homes and industries. Okay, so in our next lesson, we'll look at the uses of selected bases, right? Very good. So we consider sodium hydroxide, potassium hydroxide, calcium hydroxide, ammonium hydroxide. Then we'll look at magnesium hydroxide. So in our next lesson, we'll consider that. My name is Mr. Mpianing, popularly known as F Papa. Thank you.